Hello, Algebra 2 students. This is Ms. Peltier again for our 7th installment of our distance learning from Alvin High School for the coronavirus. This lesson is for our April 6th lesson. Remember, we're sending out 9 lessons. We give you a couple of days to work on them, so it's not super overbearing. Don't forget, we do have our Google Hangouts that you can come and visit with us. If you have questions, you will have an assignment. Your assignment for this one, as opposed to being IXL, you will have a worksheet. It will be due on the 8th, which should be a Wednesday. But if you have questions between now and the time that it's due, remember you can go on our Google Hangout. I have links on our webpage, on my webpage, as well as in our Google Classroom. You will also find in the Google Classroom your a blank copy of these notes, the filled-in copy of these notes, as well as the assignment. And so you can either download that, or if you just want to copy the problems, because there's just problems on a worksheet, you can certainly do that, and then you'll upload your assignment so that I can see how you did. So if you want to go and join our Google Hangout, remember Monday through Thursday, Mr. Cleveland does one at 9 o'clock. I do one at 11 o'clock. Ms. Blatt is at 1, and Ms. DeMond Bruin is at 2. And then I've had several ask for a later time, and so I'll do a 7 o'clock one in the evening as well, in case you are working or something and that's the best time for you to get on. So let's start our lesson for today. We are still doing equations, solving, and we're doing rational equations. The difference in what we're doing today as opposed to what we did the last time was, notice our variables this time are in the denominator. So that's what really makes it a rational equation, not just an equation with fractions. But notice our 3 steps are still the same. We're going to find our LCD. We're going to then multiply that LCD to all of our numerators, and then we're going to solve once we've cleared that denominator. So first equation, let's find our LCD. So our LCD for this problem, I have an x, I have a 5x, and I have a 3. So looking just at the numbers 3 and 5, we know the common denominator would be 15, because nothing goes into neither one goes into the other. So we just multiply the 2 numbers together. With our variable, notice I only have one x, but it's in 2 fractions. The idea that it's in 2 fractions doesn't matter. Because there's only one per fraction, we only need 1 for our common denominator. If you had a squared, then you would need a squared for your common denominator. And we'll get to one of those, so you don't have to worry. So we're going to take that common denominator and we're going to multiply everything by our common denominator. Now remember, before we could have put it over 1, multiply straight across, but we're going to use those same skills that we learned in that last one to do these and make our job a little bit easier. So once I've set it up to multiply, notice I have my fractions spread out so that I can fit these up here and write it neatly. So if you're doing your work on your page, spread those fractions out a little bit so that you have some room to work. So our first fraction, notice I have an x in the bottom, and that x reduces with the top x, leaving me with a 15 times 5. Plus, the second fraction, my x's still cancel, just like in the first one, and now my 5 reduces with my 15 to give me a 3, leaving me in the top with just a 3 times 6. And the last one, I only have a 3, so it reduces with my 15 to give me 5. So what I have is 5x times 2. So now it's a simple equation. We can go ahead and multiply our numbers. 15 times 5 gives me 75. 3 times 6 gives me 18. 5x times 2 gives me 10x. When I collect my like terms, 75 and 18 gives me 93. So if 93 equals 10x, to solve I would divide by 10. So I would get 93 over 10 is equal to x. You don't have to turn that into a decimal. You can leave it as a fraction. You do not have to turn it into a mixed number either. We like the improper fraction. Just double check and make sure that anything reduces. Now, for these, we also need to check for any extraneous roots. Now, if you recall, when we did radicals, we checked for extraneous roots, and that was what would make the underneath the radical negative. Well, now we don't have radicals, but what we do have is a fraction with a variable in the denominator of a fraction. So remember, when you have a fraction, you can never have a value of 0 in the denominator. So if I were to plug 93 over 10 into this denominator of 5x, if that gave me 0, that would not be a good answer. But because 5 times 93 over 10, I'm not real curious or care at all what it is, but I do know it's not 0. So I know that that's a good answer. So I can hang on to that. We will have some problems where we will check later, but that's what we're checking for, is we're checking for those extraneous roots that make the denominator equal to 0. Okay? So let's look at another one very similar to that one. Notice I have variables in the denominator, but this time notice with my numbers, the constants, I have a 3 and a 9, and 3 divides into 9 evenly. So for my LCD, I can just use 9. I don't need to use 27. I don't have to plug that in. It just makes my numbers bigger. It won't hurt if you use 27. It just makes your numbers bigger, and bigger numbers that you have to multiply and divide by. We only have one x per fraction, so we only need one x for our denominator. So we're going to be multiplying everything by 9x all the way across. When we do that, our x's, just like before, will cancel. 3 goes into 9 3 times. That leaves me with 3 times 4, which is 12. So you don't have to write that step before. I like writing it because in a minute, you're going to see where it comes in handy. So if you are very visual and you want to see it, you can continue to write it, but you don't have to, okay? On the next one, my x's cancel. That leaves me with my 9 times 7, which gives me 63. And on my last one, my 9's cancel, and that leaves me with an x times 5, or 5x. Once we're here, we collect our like terms. 12 and 63 gives me 75 equals 5x. When we divide by our our 5, x is equal to 15. If I were to take 15 and plug it in here, would I get 0? Nope, I'd get 45 or so. If I take 15 and I plug in there, I still don't get 0. So 15 is a good answer. Okay, now those were fairly simple problems. I do have 2 more that are a little bit more complicated for us to think about. Because, of course, when you get your work, they're never as easy as the first ones that we do, right? So you always want to stay for the second, third, and fourth. So, looking just at my numbers, notice 4 does go into 8, but 3 does not go into 8. So since 4 goes into 8, I really only need to use my 8 and 3 to find my LCD, which 8 times 3 would give me 24. Because notice 4 divides into 24, so we're good. Now noticing my variables, again, notice a divides into a squared, and I only have one a squared per fraction, so a squared is what I would want for my common denominator. So I'm going to be multiplying by 24a squared, all the way across to everything. So now you can see why I leave some space in between. That makes it easier for us to do our work. Now we start reducing. Our a squareds cancel. 4 goes into 24 6 times, leaving me with my 6 times 5, or my 30. Second one, my a reduces, leaving me with just an a on the top, and my 8 goes into 24, leaving me with a 3. So what I have is 3 times a times 3, or 9a. And And on the last one, my a squareds cancel. 3 goes into 24 8 times, so that leaves me with 8 times 2, or 16. As I solve, I move my 30 over, and I have 9a is equal to, when I subtract 30 from 16, that gives me a negative 14. So when I divide by 9, I get a is negative 14 over 9. And notice when I would plug that in, when I square it, it becomes a positive number. Any way I plug it in, it's not going to give me a 0, so it's a good answer. Okay? All right. Now, our last example. Notice it is a little bit different. Denominator-wise, it's not any different, but notice in the numerator we do have some more stuff. So it's not going to affect what we choose for our LCD, but it will affect what our work looks like. So our LCD, all I have is a 5 and a b, and I only need one b because I only have one b per fraction. So I'm going to multiply everything by 5b. Notice my b plus 3 in the top, if you would like. Put that in parentheses so you remember that is a full quantity. We don't want to break that apart, and we can't just start reducing things with it. Remember from before. So my b's cancel, leaving me with 5 times 1, or just 5. Here, my b's cancel, leaving me with 5 times 1, or just 5. And the last one, my 5's cancel, leaving me with b times b plus 3. Now this is the main reason why I like to write this step and show all that work. So now I don't forget to distribute my b. So b times b is b squared. B times 3 is 3b. So what I really have, 5 plus 5 is 10, equals b squared plus 3b. Move my 10 over, set it equal to 0. Remember, I know that I'm doing this because my exponent is squared. So we know this is a quadratic, so we want to try to factor that. So see, that factoring comes back in again. So don't lose your equal 0. We're going to factor with b and b. Our factors of 10 that add or subtract to be 3 would be 5 and 2. If you need to do your double chin method that we talked about earlier, your 5 would be a plus and your 2 would be a minus. Then we take each of those factors and set them equal to 0. And when we solve, subtract your 5 over, b is equal to negative 5. Add your 2 over, and b is equal to positive 2. Notice in the denominator, if I plug in for b, neither one is going to be eliminated because they both work for those. Okay? So don't forget, we have everything on our Google Classrooms for you. You can check my webpage if you like. And make sure that you visit our Google Hangouts 10, 11, 1, 2, and again at 7. If you have questions, make sure you ask, reach out to us. If you have trouble reaching out to us either through any of the Google things, you can always email your teacher if you're still having trouble. So I hope you're doing well. I hope everybody's staying safe. Keep your social distancing. Make sure you're washing your hands. If you haven't been watching the reports, make sure that you're aware how quickly this can spread, and you have it and you don't even feel bad yet. So that's the whole reason why they're wanting everybody to stay inside. So stay inside, away from people as much as you can. If you run into them at the grocery store, or if you're out running around or whatever, just make sure that you keep your social distancing and then wash your hands. So if you need something, reach out to us. Otherwise, stay safe. Have a good day.